Okay, so where we're picking up with naming is looking at binary acids. So the trick with binary acids is you want to look for a leading hydrogen. Okay, anything that's going to start with an H. Okay, and because it's binary, only two things there. Only two elements. Okay, binary acids start with hydrogen. Okay, so with the naming, we have to start the name with the word hydro. Okay, and then we say the anion base with ic acid. Okay, so the easiest, let's do some examples. So if I have HF, right, it starts with an H, starts with a hydrogen, and it only has two elements there. That means that it's binary acid. So if it's binary acid, I have to start with the word hydro. Then I use the base of the anion, which is fluor, and then I add ic acid to the end. Hydrofluoric acid. Okay, so these are the parts, hydro and ic acid. So hydrofluoric acid, HBr. Okay, two things, two elements, starting with a hydrogen. So I say hydro. The base of that is brome, so hydrobrome, ic acid. HCl. Two elements, starts with a hydrogen, binary acid, so I say hydro, chlor, ic acid. Okay, now, I want to draw your attention to a list. All right, this is the same list that is in your textbook. It's table 2.5. Bad news is, memorize this list. Okay, we've got a little bit of time until your next exam, and you need to have this list in your mind. Now, here's a strategy for doing that. Okay, go for the ATE versions first. Okay, and I'll explain why. Because if you memorize all the eights, the chlorate, the nitrate, the phosphate, the sulfate, then you can use a strategy to get the rest. So I'm going to use chlorate, which is right here, as the example. Okay, so if I have chlorate, which is ClO3 minus, right? And I want to make it very clear that you need to know the charges, the names, and the formulas for all of these. Okay? So if you memorize chlorate, ClO3, and if I take an oxygen away, my charge stays the same, but I have one fewer oxygen. See, ClO3 is chlorate. If I take an oxygen away, it becomes chlorite. Now, if I take another oxygen away, I keep the same charge, but now it's just ClO. Now it's hypochlorite. Hypoite. All right, now let's say if I'm starting at chlorate and I add an oxygen. Let's come up to the top here. Make this ClO4 minus. Now it's perchlorate. Okay, so there's a pattern to these things. So if you memorize chlorate as ClO3, then if you remember the pattern, you don't have to memorize all 4 of them individually. Okay? So these are called polyatomic ions. Right? And notice that they're all negatively charged except for this group at the top. These guys right up here. So there are 2 positively charged polyatomics. And we really never do anything with hydronium, so you just need to focus on the ammonium, okay, NH4+. All the rest of our polyatomics are negatively charged. Now so I can take these and treat them the same way as I would any other individual ion, right? So these are polyatomics, we sort of like self-contained units, right? So I can make ionic compounds with them, and the naming is actually the easiest one, right? So let's say that I want to combine, I have a sodium with a ClO3, right? That ClO3 is chlorate, right? And this is why I want you to memorize the polyatomics to recognize that that piece right there, all by itself, is chlorate. And then all I have to do is name the cation. So the name of this compound is just sodium chlorate. Okay, so normal ionic compounds with polyatomics, all you have to do is name the parts. There's no adding ides, there's no hydro anything, you just name the parts. Okay? Now, if you have one of those cations that makes more than one charge, you have to use a Roman numeral in order to say which ion it is. So if I gave you a formula that looks like this, okay, I'm going to use the anion to tell me about the cation. Okay, I know that iron can make a 2+ or a 3+, but I have 3, right? This tells me that I have 3 polyatomic ions, 3 of those chlorate units, right? And each one of those is a 1-. So in order for a single iron to balance out 3 negative charges, that iron has to be a 3+. Okay, so the naming is still the same, but I do have to use a Roman numeral to say that it's iron 3. So I'm going to write this as iron, and the Roman numeral 3 to tell me which iron. It's iron 3+. So iron 3 chlorate. All right, so let's look at another example of that. Let's see if I have, I'm making this up as I go. Let's say I have cobalt with 2 nitrates, right? NO3 minus is nitrate ion, right? And I know that cobalt can do either a +2 or a +3. I'm going to use the anion to tell me which one it is. So I've got 2, remember that 2 right there tells me that there are 2 nitrates there. So I've got 2 1- to deal with. So in order for that cobalt to balance that out, that has to be a 2+ ion. So this one's going to be called cobalt 2 nitrate. Okay, so the naming is with polyatomics and polyatomic ionic compounds is very straightforward. You just name the parts. But you have to first know the parts with that list of polyatomics, and then recognize when you have one of those metal ions that makes more than one charge. And that applies to when I don't have polyatomics. Let's say that I have copper chloride. Okay, binary ionic, there's only 2 elements there. But I know that copper makes more than one ion. Copper can do a 1+ or a 2+. So the same strategy exists. I know that chlorine only makes a 1- ion, and I have 2 of them, so 2 minuses. And if I have 1 copper, then that means that that has to be a 2+. Right? So the naming rules still apply. I use the name of the metal, the base of the anion with IDE. Right? So it's still copper chloride, but I have to say copper 2 chloride. Okay? So before we get into dealing with more acids, I'm going to stop this video, we'll post it, and we'll come back talking about polyatomic acids or oxoacids.